We want to define some variables to store some information, and we start with the simpler data structure, the data variables, right? So there are different types like string, which is textual data. Numbers can be integers, which are whole numbers, or it can be some floating numbers, the decimal numbers. There's Boolean values, which is true or false. Now, the problem we have on hand is shown here. Let's define some information for a person. So we need to get the person's name, age, height and weight, and then based on those information, we will calculate the BMI index, which is the body mass index, to measure certain aspects of health status, mostly whether or not this person is actually normal or overweighted, right? So eventually we want to display a message on the screen to say this person's name, actually it's Jack. So we'll say Jack's BMI is a certain number, maybe 24, maybe 23.5, something like that, right? And then we want to make a judgment. Is it normal or is it not normal? So it is something like, is it true or false that the BMI is normal? Or I think we can make it more flexible. We can say that, is normal or is not normal, something like that. Okay. Now let's try to continue with the task we just started. We define the name Jack. That's great, right? So that's already defined. But I need to do it again because, for Colab, it's a cloud service by Google. So if you actually are idle for a certain amount of time, you get time out. So let's run it again for safety. Now name is Jack, right? So now we want to say, we define a variable, which is an integer number. Age is 21, so Jack's age is 21. We just assign this integer number 21 to Jack. Now we're gonna define some height and weight information about this person in meters, right? So let's say Jack is 1.81 meters tall, and the weight is another floating number, which is a decimal number. Let's say 67.0. Okay. Now we want to calculate the BMI. So body mass index. We have a formula. So basically, the formula is simple. I didn't show you on screen, but it's just the weight divided by height squared. Right? So 67.0 divided by 1.81 squared. And then we can just quickly implement the formula here. So BMI, some number I want to use to, calculate this index. Right? One nice thing about Colab is that actually it has tons of auto completion and AI features that help you more efficiently write your code. And we'll see more of that a bit later, but right now just let me type the formula manually. You can follow the hint to complete the formula by hitting the tab key on your computer. Right? So this actually calculates the BMI. Now I want to see if it's normal, right? So is it true or false that this BMI is normal? But before that, let's take a short break to see the result. So I'm gonna just type the name of the variable, the BMI, in the end, and then I will run this cell. Now, for a variable name in the end of the cell, of the code cell, it will be displayed, right, after you run the code. Now we see that the BMI is 20.45. So is it normal? Is it not normal? Well, let's define another variable. Let's remove this. This variable is called is normal. It can be true or false, right? So let's focus on only one aspect. Let's say below 25 is normal. It could be that this person is underweighted, but let's make things simpler. So let's say BMI smaller than 25. So the second part of this expression is really that we're providing a condition and we want to verify whether or not this condition is true. Right? Now the BMI is 20.45, so it's apparently under 25, so the result will be true. And then we assign this result, which is a Boolean value, to the variable is normal. So let's take a look at this variable is normal. And then it's true, right? If you have some data from a different person, turn out the BMI is 28, then it's false because it's not normal. Okay. Now, finally, let's define a result that is called just called result, which is normal or abnormal. How do we do that? This time, let's do an if-else statement, because whether or not the result is normal or not normal depends on the value of this Boolean variable. Right? So let's do this. If is normal, so this is actually a if statement, and followed by colon. Basically, remember, is normal is either true or false, right? If it is true, then what I want to do is that on the next line, by pressing enter, something very important, you will see that actually there will be a line or multiple lines of codes to be executed if the condition is true. Right? And this automatic indentation. Indentation is very important in Python. So if you are running some codes under an if statement, and those codes, when the statement is true, should be indented. Don't remove the indentation. Okay? So then, if that's the case, let's say result is equal to normal. And then this statement is done. I mean, what I want to run if is normal is true is finished. So I will remove the indentation, meaning that I'm jumping out of this condition being true block of codes. Right? So then I will say else if it's not true. Right? If it's normal, and if it is normal is true, then I will assign normal to result. If it's not true, that goes into the else part, and I will just say result is not normal. Right? So finally, let's print a message. Let's say print a string, some textual information. Let's say Jack, but then the name Jack is stored in this variable name, right? So I will use the curly bracket to represent the content of this variable. So name, which is Jack, is Jack's BMI is result. And then curly bracket, meaning that I'm going to extract the value of this variable result. Okay. Now, it won't work in this way because if you just do this, it will just print out the curly brackets. Right? It's not really treating the name and result as variables, even though we have defined those variables. Right? So instead, we're going to put the letter F in front of the pair of quotation marks. That makes it an F string. I want to print an F string. The good thing about using an F string is that if you are using curly bracket, it is treated as variable name instead of plain textual information. Now, let's do this. Now, let's run the code. Now it shows that Jack's BMI is normal. And very quickly, let's try to say I'm increasing Jack's weight to 100.10. So now this time it's Jack's becomes much heavier. Right? Everything else stays the same. Let's run it. Now we can see that after some calculation, you can get some number for the variable, actually BMI, right? I didn't show you here, but it's imaginable it's going to be a much larger number if the weight is much higher. And turns out is normal becomes false. So I don't go to the true condition branch. Instead, I go to the else branch. So result will be assigned the value of not normal. And then when I print out this message, it will say Jack's BMI is not normal. Because the value of result becomes normal, not normal. Right? So that's the a quick example for us to demonstrate the use of variables to store different pieces of information, either based on your input or based on your calculation. Do we have any questions about this example? All right, so if we don't have a question, let's move on. Now, some slightly complicated data structures. This time, it's a bit more than one variable, but we can think of them as several variables being grouped together. Okay? So we have some data structures that we want to quickly use on this screen, but let's get started with the sequence types: list, range, and tuple. I think I probably don't have an example of tuple, but it's going to be actually quite easy. We can quickly insert one example. And then there's the interesting thing about sequence type is that the order matters. You know, how the values are arranged in terms of their orders in this data structure is important. For set, it's just a collection of items. It doesn't matter. And there's a mapping type called dictionary, dict. So we'll see that a bit later. Now, starting from list, very simple idea, just a list of variables, right? A list of values. And then let's try to construct an example of a list. The way you can define list, first of all, I need to give a name to the list. Let's call it my list, right? And then I'm going to use square brackets. Square brackets are for defining lists. You just put elements between this pair of square brackets. Let's say 10, 12, 17, 19, 42. And that's my list. Okay. Then let's just type the name of my list in the end of the cell to let the notebook to display the value of my list. And let's run it. And we can see that we indeed have assigned those values to a list, right? So we have a list of 5 elements. Now, there are other useful functionalities to extract information from lists. A very quick example, len, and then put the name of the list inside a pair of round brackets, parentheses. So then that will calculate the length of the list, right? So let's run this block of code, and we see that length of my list is 5, right? So that's a very quick calculation by using the len function. So there are many other functions, but we can always learn on them on the fly to calculate the different things about the list, right? So then moving on. Now we have a list of 5 elements, right? Now what if I want to access or display or use some of the elements, right? So how do we maybe extract one element from the list? Or maybe extract a range of elements from the list, right? So this is something we call the indexing. We provide an index, let's say index 0 or 1. One important thing is that indexes for lists and many other data structures always start from 0. The first element is called element 0. The second element is called element 1, and that's the one thing important, basic but important to keep in mind, right? So let's say I have a list, my list. Let's quickly try to view the content of my list again, right? Type the name, or you can do print my list. They give you the same result. Then we can see the content of the list. But let's say I want to only extract the first element, which is called element 0, which is 10, right? So the way we can do that is to type the name of this variable as a list, this data structure as a list, and then followed by square brackets. And then I'm going to say enter the index. I'm using 0 here, meaning that I want to get element 0. Element 0 is the first element, as I mentioned just a moment ago, right? So you will see that this allows you to extract the first element, which is 10. Okay, and you can do 2, and then this will give you the third element, right? Because things start from 0, 0, 1, 2. Index 2 is the third element, so that's 17. Okay. Now, we can also do, let's quickly look at this original list again. So we can also do negative index. For example, I can do my list minus 2. So what do you think is the result for my list minus 2? What is the element with index minus 2? Yes, please.
The second to last one?
Second to last, exactly, right? It's going to be 19, because if you see a negative index, it means that we're counting backwards. Minus 1, minus 2, so it's going to be 19. Let's quickly verify that. It's 19, right? Now, there's also something called, typically we call that slicing. For example, I can do 0, that will be 0, index 0, element 0. But then if I do 0 to 3, so let's do two things here. Let's first print the content of my list, right? Remember, if it's not in the last line, it's not displayed by default. So I need to print it if you want to see the result. And then let's do my list from 0 to 3, and let's see what's the outcome. Right, the first line is the result of the print function, so that's the full list. And 0 to 3 means that element 0, element 2, element 0, element 1, element 2. So from 0 to 3, but not including 3. Right? So basically, this is to extract a range of the elements by providing the starting index and the ending index. But you will not get the element at the ending index, but you will get the element right before that ending index. Right? So from 0 to 3 is going to give you element 0, 1, and 2. Okay? So that's actually how Python works with this kind of slicing method, which is to cut off a slice that contains a range of the elements in the list. All right, so questions? Now, I listed some exercises. Those are very simple, so probably I won't spend time in class to go over every single one of them, but they're very simple, right? You have a list, max, followed by round bracket, name of the list, that will mean the maximum element. Similarly, you can get the minimum element, the summation of all elements, right? And then you can actually try to add another element by using the append method. Okay. So let's actually, maybe we can quickly, here's another exercise, but let me quickly exit. For example, I want to quickly demonstrate one thing you can do while you are doing some coding experiments, right? So I think this is actually, let's see if it works out. For example, I have the my list, right? A collection, a sequence of 5 numbers. For example, let me write the hash sign, and that means that I'm writing a comment. That's mostly for readability. It's not going to be treated as code to be executed, right? So let's say add the number, let's say 100 at the end of my list. In the past, this is a comment. It's mostly for readability. But the nice thing about Colab with all those AI features is that now if you provide a comment, it's somehow serving as the AI prompt. Right? Now, I hit enter, you will see that it tries to implement what I mentioned in the comment. So sometimes when you're writing a code, either you can invoke the AI assistant. For Google Colab, it's Google Gemini. Right? I'll show you a bit later how to actually invoke like Google Gemini in Colab. It's pretty simple, but then another quick way is that you organize your thoughts, write the comments. It is treated as some prompts. Okay. Now, using tab key to complete the codes, following their suggestion, and run the codes, you will see that now I have one more number, 100, appended to the end of the list. Right? And that's a demonstration of both the comment as a prompt and also the append method for a list. All right, so questions? Now, the next part, what we can do is that we can define a range. A range is basically similar to a list, but it's a quicker way to define a list of continuous values. So let's do it. Let's say I'm going to define a range. We're going to call it range from 1 to 11. So it's going to be 1, 2, 3, 4 until 10. And same thing as before. If you're providing the ending index, say 11, it's not going to go until 11. It's going to stop right before 11. So it's from 1 to 10. If you want, you can assign a variable name for this data structure, a range from 1 to 10. Okay, but then let me just quickly demonstrate the result. So it's actually, as you can see, the output is simply range 1 to 11. So it's actually not very intuitive, right? What we can do is that we can convert it into a list. So range 1 to 11, not including 11. And then I include it in a pair of parentheses and then put list, which is the name of the data structure list, in front of it. That will convert the range into a list. Now we can see that it's the values from 1 to 10, right? Stopping right before 11. Okay. Now, having this data structure range is a convenient way for us to quickly define some, relevant lists we want to have. I'll give you one example, and this example actually includes, some flavor of using a loop in Python. So basically, let me first type the square brackets. You know that I'm defining a list using square brackets, right? Now, this time I want to define, as I included in the descriptions above this code cell, I want to define the list of from 1 and then square root 2, square root 3, square root 10, right? And they're not continuous values, but then it's the similar idea of defining a somewhat continuous values, but combined with the square rooting operation, right? So normally you would just type 1, square root 2, square root 3, which is a bit time consuming if you have many numbers. But one quick way to define it is that, first of all, let me import a library, import NumPy, numerical Python as NP, because we're going to use some functionality of this library. It's actually square rooting, right? So it's to do the square rooting, I want to use the NumPy package. So I'm going to do np, which is the alias of the NumPy library, dot square root. And I want to do square root 1, 2, 3 until 10, right? But then I'm going to use square root I. I is the index. But of course, if you just do this, Python will not be able to understand. And what is I, right? So you need to specify the I value. But it's actually not a simple value. It's going to be a range of values, right? So for I in range from 1 to 11. So I want to calculate square root I, but what is I? I is going to be a loop, an iteration from 1 to 10, not including 11, right? So this is a simple expression we can use. And after running this block of code, as you see, we will be able to get a list of 10 numbers. So np.float 64, this is a little bit distracting, but what's important is that it tells us it's a floating number defined by NumPy library, and the value of that number is inside the pair of parentheses, right? So it's going to be 1.0, which is square root 1, 1.41, that's the result of square root 2, etc., until the last number, 3.16, that's square root of 10, right? So this is mostly for efficiency. Sometimes you may find it useful. I want to define a long list, but then I don't want to write down every single value. So sometimes you may be able to actually use a quick loop, quick iteration, I from 1 to 10. For each of those I values, I want to do the square rooting operation. So that's how we can quickly generate square root 1, square root 2, square root 3. You can do log 1, log 2, log 3, right? And exponential 1, 2, 3, etc. Okay? Questions? Okay, moving on. Let me know if I'm going too fast and we need some moments to digest the content. Okay? Now, we just saw range and list. There's one more thing, which is tuple. Let me actually also quickly do a demonstration of tuples. And to be efficient, let me first create a text cell, a markdown cell, which is a tuples. Without much information, let me just add a code cell. Let's not, because it's a really simple data structure. Tuple is actually just a collection of numbers, right? So let's say my tuple is just similar to a list, just 1, 2, 3, 4. I mean, it does not have to be continuous. Let's say 100. Okay, and then we can look at the content of my tuple. So it's not a list, but it's called a tuple. It's a combination of numbers, not too much different from a list. And usually you can replace the tuple with list, but just to make things complete, sometimes you want to have a certain combination of numbers, and you may use a tuple. Okay? And when we need it, you can always do experiments about this. And quickly moving on. Now let's move on to talking about sets. Right? Sets is again a collection of values. You can a set of integer numbers, a set of decimal numbers, or anything. So let's say my favorite fruits. Here, just to demonstrate that I don't really need to have exactly numbers inside a list or a set, right? So now I define a set using the curly brackets. Now the three elements of this set will be apple, banana, and orange. And then the result will show that you have defined exactly this way for your set, right? Apple, banana, orange. And then let's do a small change. Like let's say apple, banana, orange, and going back to apple. So what do you think is the result? Let's quickly demonstrate, okay? Now, if you define apple, banana, orange, and apple in this set, turns out the result is still 3 values and not 4 values as you define. And that's because one important thing about sets is that it does not allow duplications, right? If 2 items in a set are identical, one of them will be removed. So a set is a collection of unique elements. It can be numbers, can be strings, can be anything. And now the important thing is that you are actually removing the repetitive items. Okay? So that's about a set. Now, dictionary. A dictionary is actually a very useful data structure because you will see it's basically somehow a set, but it's more than a set, right? It's a set that allows you to define a mapping, right? You want to provide some relationship between 2 sets of values. One set of the value is treated as index, and the other set is treated as the values corresponding to the index. So I think I have some explanations about lists and sets and the dictionaries in the slides. So let's quickly look at dictionary. So it's a set of key and value pairs. Right? So the syntax is pretty much the same as set because we have curly brackets, but every element is a combination of a key and a value. So you're mapping the key into values. And then, for example, I can have a dictionary defined like this. Then the key type is corresponding to the value of car. Right? And brand, Toyota, that's another key value pair. Right? So when you are trying to find out a certain object, and you're interested in certain attribute of that object, you can invoke the key. So, for example, brand. What is the brand? Is it Toyota or Honda or Tesla or any other things? Okay. Now, let's quickly do a demonstration. Okay. So let's say I define a student. This is a variable called a student. Okay. I want to make it a dictionary. So I'm going to provide key value mappings. First of all, let's say there's a attribute of every student being the ID. So the ID is going to be, let's say it's a text. You can make it a number or some textual information, a string, right? So let's say ID for a specific student is 1001. Okay, so that's the first key value pair. Key is ID, value is 1001, and then name. Let's say, key and value are separated by the column symbol. Name is Jack, so that's the second key value pair. Let's say gender is male, or simply M to make it easy. And then again, another string, okay? And then the courses, in which the student is enrolled, right? So let's say 2 courses. This time, the value is not a single number. We can make it a list, right? Because typically for courses taken by a certain student or certain people, certain person, it can be a collection of stuff, right? So if you want the value to be multiple elements, you can define a list. Let's say, for example, O712, right? And then let's say B700. I'm just, apparently I'm making up some course codes, but this is the idea, right? So then this is how I define a dictionary structure. Right? Key value pairs inside curly brackets, and then run the code to see the result. Precisely as what we have defined, right? So those are the key value pairs forming a dictionary object, right? Dictionary data structure. Now, it can be used to quickly identify value based on a certain attribute. For example, if I am interested in the name of this student, after defining it, I can continue with the coding in the same coding block, right? So square bracket, and that's used for indexing for a list. For dictionary, you can use it for similar purposes. But now I'm not providing the index, I'm providing the key, right? So let's say I'm interested in the name of this data structure called a student. And then I can run it. You will see that name is Jack, right, as we define. Or we can change it. For example, I can say name, I want to change it from Jack to maybe including the full name. So Jack Smith, let's say. Okay? So after running the second line of code, not only we are trying to find the name, but we are assigning a new value to the name, right? So after we have done this, let's include the name of the data structure variable and to ask the Python, to ask the notebook to display the value, right? Now the name is changed to Jack Smith because I actually did an assignment to assign Jack Smith to the value of name, like value corresponding to the key name. Or what I can do is that let's change the code, right? So what we can do is that let's say I want to add a new key. Let's say I want to do something called initials, which is not a key in the current dictionary, right? So, but I can still do assignment for a non-existing key. So let's say initials equal to JS, Jack Smith. Right? Now, this key didn't exist. By assigning a value to a non-existing key, what happens is that this non-existing key will be created and added to the dictionary. Let's actually look at the value, look at the content of this dictionary again. Now, as we can see, after assigning JS, this value, to the non-existent key initials, that key is created and added to the end of the dictionary. Okay? So that's how we use a dictionary. Right? So it's actually not too complicated, but as we will see later, this is actually fairly useful in terms of for us to quickly define, say, a row in a data set. Right? If we want to add a certain row in a data set, what we can do is to create a dictionary and to store the information of a new record, and then I will add the record into the original data set. I will find out more about that later. Now, before the break, let's quickly, this is something we have done already, so let me just skip this. Quickly, discuss Python functions. Right? So we can define a function which is just a certain combination of codes. You put those codes together for serving the purpose of generating an output from a set of given inputs. Right? And the main purpose is that it's going to be reusable, right? So if you don't define a function, you can always combine Python codes or commands together to execute a series of tasks. And this is something typically we call a pipeline, right? We run a pipeline of code to achieve a purpose. But next time you need to use the same codes to implement similar functionality, you need to copy and paste or type that pipeline of codes again. But if you have defined a function, you give a name to the function, and every time you want to use it, you just need to invoke it. Okay? Now, a very quick example about defining a function to serve a purpose. Let's say you want to do some calculate of the monthly payment of a loan, like a mortgage, or other kind of loans, right? Now, the inputs will include the total loan amount. That's important for determining your monthly payment. Let's say $10,000 or any other number. I would call it P here, right? So that's the principal loan amount. And monthly interest R. So interest is important, right? So if we don't have interest, we don't know how much we should pay each month. And then number of months, which is the duration of the loan. How soon you need to pay up for your loan, right? And the formula, I guess from finance, right? It's very simple. I will don't dive into the details. So I just provide the formula here. Okay. So based on the inputs, P, the loan amount, interest R, and how many months, it's called N. I forgot to include this number here. Let me quickly change it. So the dollar marks are just for displaying, math symbols in a nicer way. Okay. Number of month N, and then you can calculate the monthly payment M based on those inputs. Right? In other words, what we need to do is to define a function. So the way you define function is to type df, and then you want to actually quickly come up with a name of this function. So let's say monthly payment, right? So I just use the AI autocomplete function, and you can use that. It's very convenient. So following the name, I will include the inputs, P, R, N, loan amount, interest, and number of payments between a pair of round brackets, and then followed by column. Right? And then when you hit enter, it goes to the next line. Here it's already written by the AI assistant, but if you enter, there will be an indentation to tell you that now starting from here, we're writing the codes for this function. So that's a block of codes inside the function. So we needed that indentation. We need to define. Let's modify it a little bit to make it more clear. So let's say monthly payment is the variable M, right? M equal to the formula, and the formula is precisely here. Okay? I won't just go through the details of the formula, but the only important thing is that we must know some calculation mechanism, right? Now, what you want the function to spit out as the output is going to be some variables you define and calculated inside that function, right? So let's just return M, and that will give you the function, and you run it, the function is defined, and we can quickly, verify that we can actually we actually use the function to do proper calculations, right? So let's say we have 3 interest rates, but then we also, I think, did I get some information about, that's okay, we need to assign values for loan amount. Let's say what we can do is that now we have a monthly payment function that takes 3 inputs, right? P is the loan amount. Let's say we're borrowing $10,000, so 10,000, right? Interest rate, it's 1%, 0.01, let's say, and let's say this loan duration is actually, let's say, 60 months, right? And then we run this code. You will see that you need to pay $222 and 44 cents every month. Okay? Now, that's actually exactly serve the purpose of defining function, right? Provide the outputs based on your inputs in a very concise way. Once you define the function, you just invoke the name of function. Now let's quickly do a for loop to demonstrate how to use a loop to perform tasks that are similar to each other. Let's say we have interest rate R in 0.01, 0.02, and 0.025. So we don't calculate just based on one interest rate, but we want to see the scenarios for different interest rates, right? And then let's use this function, monthly payment, to do the calculation based on the interest rate. But then I need to replace 0.01 based on by R. R is going to be an iteration over 1, 2, and 2.5%. Right? And then in this loop, I did nothing. Or maybe we can make it, let's keep it this way. I did nothing but to calculate based on another interest and print out the result. Let's just quickly run it. And we'll see that as interest rate increases, the monthly payment increases from 222 to 287 for interest rate 2%, and finally 323 for interest rate of 2.5. We're going to actually start loading that CSV file into a data frame in pandas. So first step is to import pandas as PD, right? Sometimes it will throw error. It means that you haven't installed the pandas library. You have to install it. But for Colab, it's automatically installed by default, right? So now, no error. That's great. It means that we actually have the pandas library imported with the alias PD, right? Now, I want to define a data frame, which is precisely the player.csv file. So what we can do is that we can do an assignment. So the data frame, df is the variable I want to create to eventually store the table, right? So inside the computer memory. So what I can do next is that I'm assign a value to df to make it a concrete or detailed data frame. So PD, that's the panda library alias, dot read underscore CSV. That's the function for you to load any data set from a CSV file. Now, interestingly, what's happening here is that I need to specify the file name. Actually, not only the name, but the path following which you can find the file. Okay. Now, we're doing Colab, right? So, I mean, it's not really our local computer. Let's say if you are running the code in your local computer, what you need to do is that you can specify the file path. Okay. So, for example, under disk C on Windows computer, and then it's inside My Documents, and inside a folder called Python codes inside my document, and then player.csv, right? But conveniently, most of the time, I think in this course we can do this. But of course, you know, it's not too different if you are loading a local file. I just copy the remote address of my CSV file on my GitHub, so I just paste it, right? So very simple. df equal to pd.readcsv followed by the input as the remote address. Okay. Now, what happens after I execute this line of code is that now df is a data frame created based on the CSV file. So as before, let's do df, the name of the variable referring to the data frame at the end of the code cell, so that I will be able to visualize the content, right? So let me run it, and it's done, right? So as we can see, this CSV is properly turned into a data frame in pandas, and we are viewing the content of this data frame as a table. So what is data frame in pandas? It's just a data set in the format of a table. The rows are the player records, the columns are attributes of every single player. Now, it's several observations. So what do you observe about this data frame? Right? So if we quickly go back to quickly go back to the CSV file, right? You will see that it's just a table, and even though it has the name of the attributes as the columns, but it does not have any indexes. Actually, of course, you have the index provided by Excel from 1 to 14, a total number of 14 records, right? But after you load it into pandas, the computer memory using pandas reCSV function, you will see that they have created the indexes for the rows, right? Again, everything starts from 0. 0, 1, 2, 3, those are indexes of the players. And that's something somehow important because whenever I want to retrieve a player record, sometimes I need to think of, maybe it's the fourth player or maybe index 4, player of index 4, and then just like how we retrieved elements of a list, later on we'll be able to retrieve the rows. Okay. Now, what else? So we have 3 columns, right? But quickly looking at the content of this data set, what do you observe? A lot of duplicates, right? So, but it's not, sometimes if you look closely, it's not simple duplicates, because simple duplicates will be 2 rows that are exactly identical. And as we'll see later, it's very easy to use a command to get rid of the duplications. What's slightly more difficult is that, well, for example, if you compare the first 2 rows, the player name are, probably they're most likely the same player, right? But if you look at the second row, there's an accent in the first letter of the player's last name. Right? So this is kind of subtle. So it's not, they're not really, to computer, they're not duplicates. Right? They're not identical. But actually, based on reasonable logic, they are duplicates. Later on, we should remove them. Okay? So this is actually one idea I believe is pretty relevant to some elements of some projects we're going to do. So basically, we don't need to have identical records for them to be duplicates. Instead, if we have some method to compare them, turns out they're considered as highly similar, and then they are possibly duplicates, right? And what else? You see this index 5 and index 6, Maria Costa, a player name, but then probably in row index 6, right? There's a typo. So the O is replaced by 0, so that may be a typo. Or maybe if you use some text recognition tool, maybe it's misrecognized by the software app you used, right? And there's also something called NaN. N is a special thing in Python and other programming languages. It's actually, the meaning is not a number. Right? In general, it's just the NAs. So it means that they're missing, right? Somehow they are missing. So you have some player records, but you don't know who they are. And one easy way later on is to just drop them, right? Because if you don't know who they are, maybe you just get rid of those records on the easy side. And there will be other methods to deal with those NA values, depend on the purpose.